All right, so far we saw these circuits in time and Laplace on the S domain. Here we are focused on studying the transient of our circuits, and we focus mainly on the natural and forced response of our signals, or in a more mathematical terms, the homogeneous and non-homogeneous equations. For the forced response, we focus on the step input, and then for our phasors, we start going and studying our circuit in a steady state response. Our force input is no longer a step function, but rather a sinusoidal waveform. And phasors focus on time domain. What is this steady state response? So we are no longer studying or focusing the transient when we are looking at phasors, but we are looking at studying our circuit when everything is steady. And our inputs are no longer those step, but rather sinusoidal waveforms. When we apply Fourier analysis, we're studying our circuit on the steady state response as we do it in phasors, but now we're focusing more on the frequency domain rather than time domain. And our input, instead of being just one sinusoidal wave input, can be any type of input signal that you want. So what do I mean by any type of input signal? Signals or waveforms are divided in two main categories: periodic signals, and here you have signals that have a period, such as a simple sine or cosine wave, or more complex periodic signals, such as a sawtooth wave, or a triangle wave, or a square wave, or some sort of signal more complex than that, but as long as it has a period, it's a periodic waveform. And the other category is aperiodic signals, and here we have signals that they don't have a period, like for example noise or transients or pulse, things that happen just in one instant of time. So how are these waveforms now related with our Fourier analysis? In Fourier analysis you heard two big terms. So you heard Fourier series and Fourier transforms. We're going to use Fourier series to analyze periodic signals, and we're going to use Fourier transform to analyze aperiodic, and you can also analyze periodic signals using Fourier transforms.